Hi. Our talk today is about a new load balancing algorithm based on hash-based routing. But first, shortly about us. So I'm Soha, and this is Tamara. We're from SAP. We are both members of the app platform runtime working group, focusing mainly on routing topics. Today, we want to present an RFC that we recently proposed in order to tackle some of our customers' use cases. I'd like to start with a simple example that we could all relate to, since we're getting all hungry by this time. Let me take you to the restaurant. So the restaurant here is a restaurant that has 3 chefs. It serves a variety of plates. Customers basically come do the order. As you can see here, the first order is, for example, an Asian bowl to the waiter. The waiter then dispatches the orders to the chefs. So first order goes to the first chef. He prepares the ingredients and starts the rice cooker. Second order, burger. Chef 2 to the grill. Third order, pizza. The third chef heats up the oven, and then comes another pizza order. Waiter just continue dispatching the orders in a round-robin manner, as he used to do. But now we need to heat another pizza oven. This is obviously not so optimum, I would say. So given that we have a hot pizza oven already, why not dispatch this order to Chef 3 instead? So how does this fit to Cloud Foundry? In Cloud Foundry, there are app scenarios that could use or could benefit from a resource-efficient routing mechanism. So with the same example, the customers could be the web clients sending requests to the waiter, which is the Gorouter. Gorouter then routes requests to the instances, which could have caches in which some information required to process the requests is stored. So a cache here is a generic term. It could refer to open connections to tenant-specific backend databases, or could be pre-calculated local resources. So Gorouter getting the requests with a specific identifier, here as the orders, could route requests with the same identifier always to the same app instance in order to leverage the warmed-up cache. This is all without the need of an app to develop any extra logic. And this is exactly what we want to achieve by hash-based routing.
Test? Oops. Yeah. It's a little strange to be on stage. Yeah. Let's keep attention at the picture. And a client sent a request to an endpoint food.order.com, for example, to order the pizza, and use the request header X resource ID with the value pizza, for example. And Gorouter gets the request and calculated the hash of the value of this X resource ID header and map this hash to instance 3. All the next requests with the same header value, X resource ID pizza, will be consistently sent to the same instance, to instance 3, but they may be routed to another instance if this, the current one is overloaded. If another client or the same client sends another request to the same endpoint, but with the request header X resource ID and its value bool, Then Gorouter calculates a new hash and map it to the instance 1. In other words, hash-based routing focus to pin users to application instances rather than distributing the individual requests. But hash-based routing solves a particular load pattern and cannot be set or used like a generic platform setting. That's why it will be provided only as a per route option. The implementation of that was completed with EA, and it allows to set or configure specific properties on application for a particular application route. It can be configured via manifest, but as I said, Gorouter needs to know what header is important to decide to do this mapping. That's why header name is required in this case, as you can see in the manifest. Yeah, let's move to our implementation progress. We started with RFC, followed by POC in Gorouter and routing release. We try to find out what hashing approach is the most suitable for our use cases and for our performance requirements. Currently, we are in the phase to implement the feature or the new load balancing algorithm in Gorouter and routing release. And the next step will be changes in Cloud Controller. If you're interested, you can follow our progress on implementation issue linked on the slide. Also, RFC with more information about hash-based routing is linked here. To summarize our talk, hash-based routing can satisfy customer requirements with scenarios that rely in limited resources in backend service, like database isolation per tenant, or extensive but cacheable per user data. And the use of generic per router feature make it really very simple to realize our cross-component proposal, as we can focus now on implementation of new load balancing algorithm on the feature itself in Gorouter, and we only need minor adjustment in other components. Thank you.